Hello everyone, myself Nikita. I am from VIT pursuing MTech Integrated second year. My professor name is Kannadasan and my teammate is Krishna Kaushik. I am here to explain topic related to principles of compiler designer, that is LL-of-1 grammar. Initially, let's discuss steps to construct LL-of-1 grammar. Here are few steps to construct LL-of-1 grammar. Consider a grammar, check whether there is any left recursion or left factoring. If there is any possibilities of left recursion or left factoring in grammar, we need to remove those. Next, compute the first and follow of non-terminals. Now, construct predictive parsing table. Finally, parse the input string using parsing the table. Now let us get into an example to understand more about it. Example number 1. Construct predictive parsing table for the following grammar. Here is the grammar. Check whether the a, string belong to that grammar or not. Solution. In the first production rule, S implies L by A. In this first production, there is no left recurring and also no left factoring. Now, second grammar, that is L implies L comma S or S. This is in the form of A implies A, alpha or beta. From this, we can say that A is equals to L, alpha is equals to comma S, and beta is equals to S. Now, grammar taken for this is A implies beta A dash. This is the one of the main formula and this is the second. Now, A is nothing but L implies beta is nothing but S, A dash is nothing but L dash. Now, moving to our third formula, which is A dash implies alpha A dash or epsilon. This can be written as A dash, it means L dash, implies comma S L dash or epsilon. Now, the grammar taken for predictive parsing is as follows. S implies L or A, L implies SL dash, which is written from 1 and this we take it as 2, and L dash implies comma S L dash or epsilon. This is our predictive parsing grammar. Now, let us compute first and follow of non-terminals. Now, what are the non-terminals in the given question? Non-terminals are S, L and L dash. First of yes, that is equals to, this is a terminal. So, comma, and the production S implies L or A can also be written as S implies bracket of L or S implies A. A is also a terminal variable. So, first of S is equals to open bracket comma A. Now, next non-terminal is L. So, first of L is equals to, now L implies SS is a non-terminal. Therefore, now S, first of S, as the immediate variable is a non-terminal, we need to write the first of S. What is meant by first of S? Open bracket comma A. The next non-terminal variable is L dash. In the given prediction, comma is a terminal variable, so it can be considered And this production can also be written in this way: L dash implies comma SL dash, or L dash implies epsilon. Epsilon is considered to be a terminal variable, so that can be included. Now let's move on to the follow. First non-terminal is S. So follow of S, that implies. Now how to find the follow of S? In the given predictive production, check right hand side RHS where the S variable is present. It has been present in the L implies SL dash. Adjacent to the S there is a non-terminal. So we need to consider the first of L. What is meant by the first of L or L dash? First of L dash is bracket comma epsilon. It is mandatory to be remembered that in follow epsilon should not be considered. Therefore bracket comma now L. Let's check where L is present in the RHS side. It is present in the production. S implies bracket of open bracket L close bracket or A. Now the immediate term to the L is a terminal variable, that is open bracket. So open bracket comma, and as it is a first production, we need to consider dollar symbol in the follow of S. Now next non-terminal is L. So follow of L is equals to, let's check where L has been present in the RHS side. It has been present in the production. S implies open bracket L close bracket or A. The immediate or adjacent to the L is open bracket, that is terminal, so it can be considered. Next non-terminal is follow of L dash, that is equals to, now follow of L dash, check where L dash is present in the RHS side. It has been present here. As there is no any terminal beside the L dash, take follow of L. That implies follow of L dash is equals to follow of L. Follow of L is open bracket. Now these are all follows of non-terminal variables. Now let us construct the predictive parsing table. From the above points we have discussed, now we need to construct the predictive parsing table. Predictive parsing table: A open bracket close bracket comma, these are the terminal variables in the given grammar, and dollar symbol must be included. S capital L L dash, these are non-terminal variables. Now let's find the relation between S, A. As we can see, first of A is open bracket and A. Open bracket and A. Let's check the relation between S and A and S and open bracket. From the above production, S implies A. For the open bracket, it's S implies open bracket L close bracket. Next, for L, first of L is open bracket and A. So the relation for L and A and L and open bracket. As there is only one production, it is applicable to both. S implies SL dash and L implies SL dash. Next, for L dash, it is a closed bracket and epsilon. So let's fill up this. L dash implies epsilon and L dash implies comma SL dash. It has matched with the terminal variable. Now here we have constructed the predictive parsing table. Now let's move on to our last step, that is parse the string using the parsing table. From the given question you can see that our string is A comma A. It's an open bracket A comma A. This is our table. Here we write the state, input as well as actions. First, the initial or starting variable in the production is yes. Starting variable in the production is yes. So we need to mention $yes as it is the first production. Input, the given string is a comma a and dollar should be present. Now, what is the production of yes that matches with the given string? It's S implies A. So let us write the string S implies A. The another production of yes is S implies open bracket L close bracket. Now, this open bracket or the starting terminal variable has to match with the starting terminal of the given string. Now in the state, this string or this action has to be written in a reverse order. It means dollar, open bracket, L and close bracket, and the input continues. Now dollar, open bracket have been matched, so we can pop out this L, A comma A, dollar. Now the production for L, is SL dash. So the production for L is SL dash. So the L is replaced by SL dash, and this SL dash has to be written in a reverse order in the state. Dollar, closed bracket, L is replaced by SL dash and has to be written in a reverse order, and the input continues. Now let's check for a S. Production of yes that matches with our input string is S implies A. S implies A. A matches with our initial variable of the string. So now here the S is replaced by A. Dollar bracket L dash A. As A both are the same variables, it will be popped out. So further it gives dollar bracket L. As A got popped out, A, dollar. Now the production for L dash is comma SL dash. So L dash implies comma SL dash. Now this L dash is replaced with the comma SL dash in a reverse order. This implies dollar bracket L dash yes comma A bracket dollar. As the both are the same, they will be popped out. So this implies dollar bracket L dash yes A bracket dollar. The production of yes that matches with the initial variable of the string is S implies A. Now this S is replaced with A. A both are the same, so they will be getting popped out, and this implies dollar bracket L dash bracket S dash. Now the another production of L dash is epsilon. So the another production of L dash is epsilon. Let's substitute L dash implies epsilon. Now L dash is replaced by epsilon. Dollar bracket L dash is epsilon. As epsilon has no value, we can neglect it. Open bracket same, so they can be popped out, and finally dollar has been left over. As both are matched, the string is accepted. Now let us step into example number 2. Show that following grammar: yes implies production number 1, production number 2, A implies epsilon, B implies epsilon is LL of 1 grammar. Now consider the grammar S implies capital A, small a, capital A, small b, and this can be written as the two productions, capital P, small a. A implies epsilon and B implies epsilon. Now we will compute first and follow. First one, uh, non-terminals for the given grammar are capital S, small a, and capital B. Now, first of capital S is equals to, now first of yes, from the above grammar, A implies epsilon and B implies epsilon. So, by substituting epsilon in the place of A and B, S implies small a and small b. These are all terminals. And S implies, as epsilon is got substituted, small b and small a. First of S is equals to A comma B, terminals. Next, first of A is equals to terminal variable epsilon. First of B is equals to epsilon. Now coming for the follow of, first non-terminal is S. Follow of S, as S is not present anywhere in the RHS side. S, as it is as S is a first production, dollar symbol must be included. Next, follow of A. The immediate follow of A is small a and small b. Same as follow of B, that is equals to small b and small a. Now in parsing table, A, B are terminal variables and dollar must be included. Yes, A and B are non-terminal variables. Now first of yes is A comma B. So the relation between S and A is capital A, small a, capital A and small b, and the relation between S and B is this one, capital B, small b, capital B and small a. Next, the first of A. First of A is epsilon and the production of A is only one production for A, that is A implies epsilon. That is follow of A. Follow of A is A comma B. So the relation between A and small a is A implies epsilon, and as there is only one production, it is applicable to both. Now B. First of B is epsilon. So consider follow of B. Follow of B is B comma A. The production of B is B implies epsilon, and as there is only one production, it is applicable to both A and B. Now this is our parsing table. Stack, input, action. The first variable is yes. Dollar symbol has to be kept. The string that we have taken as an input buffer is BA dollar. The production of yes is capital B, small b and capital B and A. Now this S is replaced by this production in a reverse order. The input string continues. The production of B is epsilon. B implies epsilon. Now let's substitute the epsilon in the stack. As these are same variables, it will be popped out. So further it gives dollar $AB and the input buffer is A dollar. Now again the production of B implies epsilon. Let's substitute epsilon in the place of B. It gives A and the input buffer continues. As the variables are same, it will be popped out. And dollar continues. As they got matched, the string is accepted. Hence we can say is that the given grammar is in the form of LL of 1.
Hi guys, This is Krishna Kaushik from Vellore Institute of Technology, CSE branch. Just now, my teammate had explained few examples on LL1 grammar and how to find whether a grammar is of LL1 or not. And hope you understand the explanation. Now let's discuss few more variations of this LL1 grammar by solving some more problems. Let me get the question first. The question number 1. First of all, let me give the small detailing about the question and then about the solution. So guys, here is the question. So you can see the I'll just read out the question. Consider the grammar, okay? S tends to I, E, T, S, S dash, or A. S dash gives rise to E, S on epsilon. E gives rise to B. So the question is whether it is LL1 grammar. Give the explanation whether these symbols or terminal symbols. So now let me write the three production rules here in the solution. So the production rules are S tends to I, E, T, S, S dash, or A. S dash tends to E, S, or epsilon. E tends to B. So first, let's reconfigure the terminals and non-terminals based on the above grammar. So let's do it. NT stands for non-terminals. So non-terminals are S, S dash, E. So these three are the non-terminals. Coming over the terminals, so this T stands for terminals. So like this I, small t, A, E, and B. These are the non-terminals. These are the terminals. Sorry. Now let's start the step-by-step deviation of first and follow. Let's begin with the deviation of first. Now it is always a good idea to start with the last non-terminals. The reason behind that is, notice this, we are dealing with the top-down pressure without backtracking. Now we can't really handle ambiguity except for operator precedence pressure. So definitely the grammar that we will be dealing will be an ambiguous. Thereafter, this pressure is a top-down pressure. Now top-down pressures can't deal with the left recursions. If left recursions are there, then there is a possible of getting into infinite loops. So now for this grammar, we need to be starting with each of the non-terminals one by one and derive the first of all them. So starting with, so I have written the non-terminals here, and now let's derive the first of non-terminals. Okay, first of non-terminals. So the first non-terminals is, let's start with S. First of S. Okay, guys. So let me give you a small detailing about how to find the first of a non-terminal. So look at the production values where this S is involved. So you can see here in this production value, the S gives rise to I, E, T, S, S dash, or A. So under the first of S, we can write the terminal I. And this S also gives rise to this A. So I can even write this A. Now, are there any other things that can be included under the S first of S? Yes, exactly. There is no other things. So now let's dive into the second non-terminal. Is S dash. So coming about the S dash, here is the S dash one. So this S dash gives rise to this small e, which is a terminal. So we can just include this E. And moreover, don't forget that this S dash also can be rewritten as this epsilon. So it will be also comes under this first of S dash. Now that's it. Next, first of E. So there's only one production rule which involves this E non-terminal, and that's E gives rise to B. So we can directly write this B under the first of E. So here we are done with the first of these non-terminals, everything. And the next step to be taken is to find out the follow of these non-terminals. So here we got the three important rules which can be useful for determining the follow of the three non-terminals. Started? So guys, here are the three rules. The first rule is the following terminal symbol will be selected as the follow. So for example, if you take follow of A, and in the production rule, it is like A gives rise to A, B. So now for the follow of this A, you can directly write B as the answer. This is the meaning of this first rule. So coming up with the second rule, the first of the following non-terminal will be selected as follow. So now, like if you are in a case like just slightly changing this equation, A is B. and this B gives rise to A, B something. Okay, think of this. Now you're asked to find out the follow of A. So now A is followed by B. So as per the second rule, you can just follow of A is equal to first of B. So this is the meaning of the second rule and the third rule. So like if you are in a situation, for example, A is equal to small a, capital A, and you don't have anything that this A will be followed by. So like it's null, like epsilon, maybe null. So you don't have any value here, like any non-terminal here, or maybe a terminal. So in this case, we can directly follow of this A is equal to, this is RHSA and this is LHSA. So this A will be on the right hand side. Follow of A. This is the meaning of this third rule. So okay, let's move to the follow section of this question. Uh, Follow of this non-terminals. So once again recalling the non-terminals, what are they? S, S dash and E. S, S dash and E. So first of all, let's start with the S. Follow of S. So let's look at this protection value where S will be involved in the right hand side. So here it is S and here it is S. So let's take these two protection values. So the protection statements are uh, S tends to I, E, T, S, S dash and A. Next one, S dash is equal to E, S, epsilon. So remember guys, you have to take the right hand side S, not in the left hand side. So the protection rules which involves this S in the right hand side, you have to just take them. Ignore the rest, okay? So now as per the three rules, uh, I am going with the second rule. So like you can see, there is a S dash, just the S is followed by this S dash. So I can directly write follow of S is equal to first of S dash. And let's go for the first of S dash. This first of S dash is equal to E comma epsilon. Remember guys, one more thing. For the follows, you cannot include this epsilon symbol. Only the terminals are included. No epsilon. We have to eliminate this epsilon. I tell you that. So let's first include this E. And coming out the epsilon. So think like if you substitute this S dash as an epsilon, so it'll end up with nothing. Just S in the right and rightmost part. So as per the third rule, when this S is the RHS most thing, so you have to consider this follow of S is equal to follow of the LHS one. So this S is gives rise to S. So you can just include this dollar symbol. So this is the follow of S. So for the next non-terminal, follow of S dash. So let's take the protection rules which include S dash in the right hand side. Okay, there's just only one rule. If you look up, there's just only one rule which includes S dash on the right hand side, this one. So let's take that rule. So S tends to I, E, T, S, S dash or E. So now you have nothing to be followed by this S dash. So just go to the third rule for this follow. So like you can just write follow of S dash is equal to follow of S. So what is the follow of S? E comma dollar. So this will be follow of S dash as well. And next one, follow of E. So for this follow of E is included only in this production rule. I'll write the production rule. S tends to I, E, T, S, S dash or E. So now just look at the E. So E is followed by a terminal symbol. So as per the first production rule, the following terminal symbol will be selected as the follow. So you can directly select E as the follow of E. So follow of E is equal to T. And we are done with the follow symbol. So now let's start making the predictive parsing table. So let me tell you how to construct this predictive parsing table. So in the table, in the left hand side, you have to include this non-terminals. So what are the non-terminals? S, S dash, and E. So on the uppermost side, you have to include these terminal symbols. So terminal symbols are A, B, E, T, I, and this dollar symbol. So remember guys, first of all, look at this first of the every non-terminal symbols. So for the first non-terminal S, this is, if you take for the first of S, it will be I and A. So just write this production value under this I and A sections in the predicate passing table. So first I encoded with the A, so I can just write S tends to A, and B, with B I don't have anything in the first for the S, so I can't write, only I is left. So I'll just directly jump to the I thing. So I'll write the production rule here, I E T S S dash, and now we are done with the S thing, and now coming to S dash. So for the S dash, this first of S dash, it's E and epsilon. So first let's give it for the E. So S bar tends to ES. So guys, whenever you encounter a epsilon on the predictive passing table, you have to look up for the follow of S dash. This follow of S dash, it's here. So you have to even mark for this. If you encounter an epsilon in the first of any non-terminal while you putting them in the passing table. So okay, like you have to again put S dash because it's E, so epsilon, and for the dollar, S dash tends to epsilon. And now for the production rule E. So let's go to the first of E. The first of E is B. So just write this under the B. So E tends to B. So now we got this multiple values for the S M of S dash comma E. So if you encounter anything like this, then you can directly conclude, therefore, the given grammar is not LL1 grammar. And one more thing, they gave some symbols and asked that if these are the non-terminals or not. So let's go for them. So the thing is I, T, E, and A and B. So these symbols are non-terminals. Oh, sorry, terminals. As you can see in the first slide, we divide the non-terminals and terminals. So I'll give the explanation why these are called terminals. These terminals will not be representing on the left-hand side in any production rule. Look at here. Like in the three production rules, this I, T, E, B will never come in the left-hand side. So these are called terminals. Production rule. Look at here. Like in the three production rules, this I, T, E, B will never come in the left-hand side. So these are called terminals. ఏరా రే రే ఏరా నిద్రపోయినావు నాపరా పాస్లో ఉందా ఎంతసేపు పట్టుంది రే లేరా I know many of you have a slight questioning faces and some sort of doubts about the first and follow operation discussed above. I have got a few more types of these problems which will just focus on the follow and first of the non-terminals. So here is the first question. Let me write the question. P gives rise to X, Q, R and S. Q gives rise to Y, Z and Z. R gives rise to W and epsilon. This S gives rise to Y. So they ask like find the follow of Q. So now for finding the follow of Q, just look at this production values. Like wherever you encounter Q in the right hand side, just pick them. So here, now. So just write that P tends to X, Q, or S. So here, as per the second production rule we discussed earlier, the first of the following non-terminals will be selected as follows. So just after the Q, we encountered R. So this Q is followed by R. So this follow of Q can be written as first of R. So let's determine first of R. So the first of R is directly given to R tends to W or epsilon. So first of R is equal to this W and epsilon. So and one more thing, epsilon can't be included under the follow section. So you can directly write this W, but for the epsilon, you have to substitute in the R position. So if you substitute epsilon in this R, the equation will be like P gives rise to X, Q, epsilon will be negligible, and S you can encounter with S. So again, if you go to the second rule, this Q is followed by S. So now let's go for this. Let's find first of S. This first of S is directly Y. So you can just write Y. So now, therefore, the follow of Q is equal to W comma Y. That's it. And second question. The production values are S tends to A, B, C, D, and E. And next one, A tends to small a and epsilon, B tends to small b and epsilon, C tends to small c, D tends to D and epsilon, E tends to small e and epsilon. So we're asked to find out the first and follow of these non-terminals. Find out the first and follow of these non-terminals. So guys, first step, you see these are the non-terminal things. So like just divide this first column and this follow column. So first for the S, first of S. So first of S is there, it's an A. So just go for A. So if you go for the A production rule, you can encounter with the A small a. So just write small a, and even you can be getting this epsilon symbol if you go with the A. So just replace this epsilon with A here, so it will be negligible, and the production rule will be like S tends to B, C, D, E. So if it is S tends to B, it's not a non-terminal. So just go for the B production rule. So it's a terminal. You can write B. Even if you go with B, you will be encountered with the epsilon. So just put epsilon, epsilon. So these two epsilons will be negligible, and you will be starting with the C non-terminal. So if you go with the C non-terminal, the C tends to only the C terminal. So just write C. You can't be putting C as an epsilon because you didn't have the production rule as C tends to epsilon. So you can stop with it. So now for this first of A. So first of A is just the terminal A and this epsilon. And first of B, it's B and epsilon. First of C, it's just C. First of D, it's D, comma epsilon. First of E, it's D, it's E, comma epsilon. And now coming about the follow. So just first follow of S. So follow of S. Just look at this. Have you ever encountered S in the right hand side? No, 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 no. So S has nothing. So just like dollar. So now coming about the A. So just look up for the A. So here it is, and nothing else. So if you go with A, so as per the second rule, this B is A is followed by B. So just look at the first of B. So if you look at the first of B, you can directly write B, comma epsilon. And remember, epsilon can't be written in the follow. So epsilon will be substituted here. And if it is substituted, and it will be remaining with A, C, D, E. So again, coming with the rule 2, here you have A, C. So A is followed by C. So first of C. So first of C is C. So you can end up with C. That's it. So if you go for B, follow of B. So follow of B will be starting here. The same thing. So if you go with B, B is followed by C. So as per the second rule, follow of B is equal to first of C. So what is the first of C? It's C again. So just write C. Coming over the D. If you go for the D, it is followed by E. So what is the first of E? First of E is small e, and this epsilon. Epsilon can be included just as A and B. So if you substitute epsilon in the E, D will be left with nothing. So if it is nothing as per the rule 3, so follow of D is equal to follow of S. What is the follow of S? And just dollar. So just write the dollar and follow of E. So the follow of E, here is the E, but there is nothing, it's null value. So as per the rule 3, just follow of E is equal to follow of S. So what is follow of S? It's just dollar. That's it. We're done with this first and follow. I guess now you have some clarity over this first and follow. Now I'll continue with a question, main question. So coming up with the third question, I'll just write the question. So the production rules are D tends to TL and L tends to L comma ID or ID. T tends to int or float. These are the three production values, and they gave three questions, sub questions for these production values to find. The first one, remove left recursion if it's required. Second one, find first follow for each non-terminal for resultant grammar. Find out the first and follow. Third one, construct LL1 razor table. And the fourth one, pass a string following string. The following string is int id comma id hyphen. So this is the following input. So let's get started. So first of all, for the first solution, first subquotient solution, formula for removing the left recursion is as follows. Okay, like if A tends to A alpha or B is the rule. So among these three production rules, if the rule is just as like A tends to A alpha or this beta, then it can be converted to. So this can be converted to A tends to beta A bar and A bar tends to alpha A dash or epsilon. So just compare with this. So let's go for the comparison things. Now for the first production rule, D tends to DL. Here no action as the rule is not left recursion, so no action will be taken. For the second production rule, L tends to L dash comma ID or ID. Here you can observe this left recursion. So to remove this left recursion, just compare with the previous equation. A tends to A alpha or beta. A tends to A alpha or beta. So I can write the production values as L tends to ID L dash, L dash tends to comma ID L dash, L dash tends to epsilon. These are the new production rules. So the third production rule, D tends to int and float. These two values or this terminal value, so there's no left recursion in this, so no action will be taken for this. So now let's get started with the first of these non-terminals. So first let's go with this D. So writing like first of D is equal to, so check for the D where it is written in the left hand side here. So it's giving to a T and L, so there is no terminal in the starting. So if you go for the T, it is giving for int as well as float. So just write int comma float. So this is the first of D, and next the next non-terminal is L. So if you see for L, this L is directly giving to this non-terminal ID. So you can just write the first of L as ID. The next one L dash. For the L dash here, it gives this comma as a terminal and this epsilon as well. So just include both of them for the L dash, comma and epsilon. Next one, first of T. If you go with first of T, and this just int and float. So just write is int, comma float. That's it. And now coming for the follow of this non-terminals. So let's start with the D. So if you look up for the D where it is in the right hand, there's nothing production rule that involves D in the RHS. So just write D as this dollar. Next for the non-terminal L. So just look up for the L. So L is there here. So this D tends to TL. No, wait. Wait. D tends to TL, comma. So L is followed by this symbol, punctuation symbol. So this as per the production rule number 1. So for the rule number 1, you can directly write a terminal as a follow of the non-terminal if it is followed by a terminal. So this can be written as, that's it. And for the L dash, this L dash is repeated here and here. So just take both the production rules and look for this. This L dash is followed by nothing. So you can, as per the rule 3, you can take follow of L. Follow of L is this symbol. You can just write this symbol for that. And follow of T. Follow of T. So yeah, T is repeated here in the RHS side in the first production rule. So as per the rule number 2, this T is followed by L. So if it is followed, you can just write first of L will be the follow of T. So what is the first of L? First of L is ID. So you can just write ID as follow of T. So we are done with the second sub question, follow first and follow. And coming to the third sub question, just write the terminal symbols in the upside and non-terminals in the downside. So writing the non-terminals, these are D, L, L dash, and T. And coming over the terminals, there are ID, comma, int, float, punctuation symbols, and this dollar. So just look at for the first of D. First of D is under int and the float. So you can write D is equal to TL under this int section and D gives rise to TL under the float section. That's it for the D. Next, look up for the follow of L. Follow of L is just for the ID. So just write L gives rise to ID L dash under the ID thing. L gives rise to ID L dash. Now looking for the L dash thing. So here L dash include epsilon. So you have to include this both first and follow of this L dash. So looking at the first thing, comma. So L dash You can use this one. L dash gives rise to comma id l and the comma thing. L dash gives rise to comma id l dash. And for the coming of the epsilon thing, you have to use this follow of L dash. Follow of L dash is just for this punctuation symbol. So L tends to epsilon. L dash tends to epsilon for the punctuation. Epsilon. And coming out the T, if you look up for the first of T, it's just int and float. Just write T used as to int or float under this float and int things. So if you write T tends to int or float, T tends to int or float. We're done with the third part, like creating a predictive parsing table. This is parsing table. So coming to the fourth part of the question. So it is for passing a string input into this production rules. Okay, the input is int id comma id punctuation. So now there will be a stack input and this action taken. So first of all, stack will be filled with the starting production rule, that is this d gives rise to t. So the d will be the starting thing. The stack, the input will be int id comma id. So the first action will be like d tends to tl. So if, as you know, the stack will be reversing the order, so you can write like replace this d with this action, so l and t. Now this will be same, nothing will be popped up. id. So now you can use action like t is equal to int, because you have the int on this RHS side. So if you replace t with the int, you can just cancel int on the both sides. So like here int, here int as well, id, id, no equation. So now just cancel these both things, ints, and just write like l, id, comma id. Here, if you look up the production rule where l includes id l dash, you can use this. L gives rise to id l dash. If you replace this L with this id l dash, this will be looking like id and l dash. Oh, sorry, the stack will be reversing the order. So this l dash comes first and the id. So here, nothing. Here you can cancel this id and id. So the next step will be like l dash, id will be cancelled. Here too. Now you need to cancel this comma symbol. So you have to replace l dash where you get a comma here. So like this equation, you'll get a comma at first. So you can use this production rule. L dash gives rise to comma id l dash. So if you just replace with the l dash with the comma id l dash, it will be looking up like l dash id and comma. So here comma id, that's it. So now there's no action to be taken, and you can just cancel these two commas and you can write the rest things, al id, here id. So now you can use no production rule as there's a direct thing id id, so you can just cancel that. So the next one is l. So l, here you will be reminding with this question symbol. So for this, so it's l dash, right? Yeah. Now you can write this l dash. For this rule, you can just use this epsilon, whereas l dash tends to the epsilon here. You can use that production rule for this thing. So if you use that production rule, I will be replacing this l dash with the epsilon symbol, so it will be negligible. You can just erase it. So now we'll have two things in common, and you can easily pop them out. You'll be left with a dollar symbol. If you encounter this dollar symbol at the end and nothing in the input, so your action is correct. Accepted. The string is accepted by the rules. So guys, here we discussed about this LL1 Parser, top to bottom